Okay, let's start the exercise. Exercise number 1. I'll give you a combination of series and parallel resistance. Okay, so there are two different terminals, X and Y, and between them there are resistance or resistors. Okay. Resistors are arranged in parallel and also arranged in a series. So the first question is, what is the combined resistance between or connected in parallel? It is asking about the resistance or the resistors in parallel. Which one? The one is arranged in parallel is this. Let's remember the formula, how to find the total resistance in parallel. It is said that 1 over R parallel equals to 1 over R1 plus 1 over R2. So this is the value that we are looking for. So let's take R1 as 300 and R2 as 100 ohm. So this is basically math, a fraction. So you have to add a fraction. How to start with? First, you have to find the common multiply of 300 and 100. So the answer is 300. Why? Since 300 is basically the multiply of 300, and also 300 is the multiply of 100 as well, right? So we don't have to multiply this, it's too large. You can also start, or you can also find a common denominator with 300 times 100, but it's gonna be too large. Okay? So I'm not gonna do that. I'm gonna choose 300 as the common denominator. So there would be adjustment in the numerator. How do we do that? 300 divided by 300 times 1. It's 1. Simple. Second fraction. 300 divided by 100 equals to 3. 3 times 1. It's 3. So after we're done the common denominator, we don't have to deal with this anymore. We deal with the upper numbers. It's 1 plus 3 equals to 4 over 3. Are we done? Not yet. Since this is the value of 1 over Rp or parallel resistor. This is not the value that we are looking for. So what would that be? We switch. We turn it upside down. Since we're not finding, or since we're not looking for the value of 1 over Rp, we are looking for Rp over 1, or basically Rp. So as a consequence, we have to turn upside down the numbers. 300 divided by 4. This is the value that you're searching for. So Rp equals to 300 divided by 4 equals to 75 ohms. This is the total resistance or the combined resistance connected in parallel. Done. Okay. Start, or let's move on to question number 2 or part 2. What is the total resistance between both terminals? Where are our terminals? This is terminal X, this is terminal Y. So what they mean is the total resistance, the total resistors in our circuit. So we have to combine the parallel, this one, and the series one. Okay? So since the parallel circuit here, the parallel resistors can be simplified into 75, and we can remake or rebuild our circuit into like this. So what do you think? This circuit looks very similar to series. So the total resistance would be 75 plus 55. As you know, in series, yeah, we don't use the fraction like this. We add them up, right? You still remember, right? So the answer is 75 plus 55 equals to 130 ohms. Alright, this is the total resistors between two terminals. Let's move on to the exercise number 2. Okay, let's start number 2. So for number 2, we're still using the same circuit from number 1. So I'm just gonna draw it again. Okay, now there is an additional information about the circuit, that the power dissipated in resistor 55 ohms is 0.2 watts. There is a power, the power dissipated. So the question is, calculate the current that flows to resistor 55 ohms. Flows through resistor with 55 ohms. Okay, so the power dissipated is known, the resistor is known, 55 ohms. So how do we start with, or where to start with? So in the previous topics or materials, we discussed about the formula of how to define power dissipated, or dissipation power, or power dissipated. That P equals to V times I, but in this case, we should modify this formula into V squared over R. Or we can also start from I squared times R. So I think from these three formulas, they're basically the same, and they're basically coming from the same main formula, but we just modify them. So which one of this formula that you think work best to our question? Okay, that again. The power dissipated is known. This is P, this is R, and the question is current. This is I, this is R, this is P. So find the formula that contain those three aspects, or those three letters or symbols. Then we go to this, right? Since there are P, I, and R. So we can start writing P equals to I squared times R. The value of P is very obvious here, 0.2. I is unknown, since we should find or look, we need to find this value, and R is 55. So, the value of I squared would be, in math, we should move the 55 to the left side, right? So, how should I move the 55? 55 and I squared is at the same level. So if this number moves to the other side, it will be a division. Now it's time to replace. I squared equals to 0.2 over 55. Make sure the known value or the unknown value is on the left side. Okay, so what is the value of 0.2 divided by 55? So in math, we can use calculator, right? But this time, I'm going to show you how. So 0.2 is basically 2 over 10 divided by 55. So I'm going to do 2 over 10 divided by 55 over 1. So from division of fractions, I'm going to convert this division to multiplication. As a consequence, the second fraction will be turned upside down. So I got, we can simplify this. So 1 over 5 times 55. The answer is 1 over 275. So I squared, the value of I would be the square root of 1 over 275. Now let's check out on calculator. Okay, so in A level, you know that it's allowed to use calculator. So I'm going to use calculator. So 1 over 275 is basically 0.0036. So the square root of 0.036 is 0.189. Can we round this off? Yes, we can. It's basically 0.2 ampere. This is the value of I that flows through the resistor 55. Should I move here? Okay, so, oh wait, right there. Question part 2. Now find the current that flows through resistor 300 ohm. Now we got I, the current that is flow through resistor 55. Can we conclude something from this value? Well, basically, if the current, I'm going to review again how the current flow through this circuit. So, if the current start from here, then it will go to the branches. It will branch out there, and it will meet at this a point here, and it will unite again. It will mix again. So the flow, the current that flows through here is the same as the one that flows through here. Why? Since this branch is met at the point of here. So we can make sure that the current which flows through here equals to the current that flows through here. Or we can say that this is the total current and this is the total current as well. So the value that we just get is the total current. It is the current that flows through the resistor of 55. So IT, or total current, is 0.2 ampere. Okay. Now, how do we deal with the current that flows through the branch to the one of the branch? It's right here. So how to start with? So I'm going to start with finding the voltage of this resistor. So I'm just going to put the number on each of the square, on the resistor. Let's name this R1, this is R2, and this is R. So this is resistor 3. So we got the value of R3 is 55. I3, or I total, 0.2. What can be derived from this two values? It is the value of voltage. The value of voltage is I times R. So we got 0.2 times 55. The answer is 11 volts. Now let's view this circuit as a series. So in the previous video, I draw a circuit like this. So this 75 ohms is representing parallel circuit with the total resistance is 75. Now if we view this as series circuit, then one rule is applied. What is that? Since we have the value of voltage, then we should relate the connection to voltage. What happens to the voltage in series circuit? So what we can do here is that the voltage on here and And here, I'm going to name this VP since it's from the parallel circuit. It's V3. So our total voltage equals to VP plus V3. Remember, this rule is coming from the previous topics about series circuit, where in series, the total voltage on each resistor are summed up, so you will get the total voltage. How do we deal with this? So the total voltage here is basically I times R. Definition of V or voltage is I times R. I times R. I times R. First, the known voltage is V3, right? This is V3. It's 11. So this value is 11. Done. Now, is there any value that is being known before? Yes, we have. IP. Yeah. So IP is the IP equals to the IT. Yeah. Why? Since IP is here. IP is current that flows to both branch. So it's gonna be equal. Okay? So IP would be 0.2, and the RP equals to 75. And this is IP, RP. Sorry. RP means the total resistance in parallel. 75. It's 11. So 75 times 0.2 equals to 15. So the total voltage in the circuit or between two terminals X and Y is 15 plus 11, which is 26 volts. But it's not our point. Our point is finding out the VP. The VP is 15, right? So this VP is 15, which is 11. So I'm going to take this number to here. So we're going to focus on finding the current that flows through 300 ohms. Now, after we got the value of V here, I'm going to break it down again. This is I equals to 0.2. You know previously that the total current is 0.2. Okay, so 0.2 is branched out, but we don't know. We have no idea about the current that flows through each of the branch. Okay, so our point is from the voltage 15. Okay, 15 voltage. In parallel, the voltage is the same. Okay, it's in series. The voltage is added. In parallel, the voltage is the same on each branch. So what I want to say is voltage on R1 equals to voltage on R2. So voltage 1 equals to voltage 2 equals to 15. Right? The voltage in parallel circuit equals the voltage on resistor R1 equals to voltage on resistor 2, which is 15. So how can or what can be derived from this number? We can derive from V1. Why? Since 300 is resistor number 1. V1 or V equals to I1 times R1. V1 is 15. I1 is unknown, but that is our main question so far. And R1 is 300. I1 equals to 15 divided by 300. It's gonna be 5 over 100 equals to 0.05 ampere. So part A equals to 0.05 A. Done. This is our answer. Okay, so I think it's done. Okay, now let's move on to the final question. There are two different circuits or network. Network 1 is there's one circuit, one resistor in series and two in parallel. One in a network 2 we got one series resistor and two parallel. So let's compare, or what is the ratio of total resistance of network 1 and the total ratio of network 2. Okay. So network 1, the resistor R is not a big deal, right? So you should focus on the parallel one, this. Okay, let's find out the total parallel resistor. 1 Rp equals to 1 over 2R plus 1 over 2R. 2R each from the resistors. So again, we deal with fraction, so we have to find a common denominator of both fraction. But this, or both fraction already has the equal or the common denominator, which is 2R. So we don't have to find other common denominator. Let's just continue the calculation. We just need to write down once through R, and then the upper value 1 plus 1 equals to 2. And then again we're using the flip. So we have to flip this, or we have to turn it upside down. Again, Rp divided by 1 equals to 2R divided by 2. So 2R divided by 2. In math, we can cancel out the same number on upper and the lower level. So the value of Rp is simply R. But are we done yet? Not yet. It's not yet. We still need to find the total resistance on R and R. So to find the total resistance, we should add this R with this. So R plus the Rp. And the value of Rp is R. So R plus R is 2R. Done. So the total resistance from network 1 is 2R. Now let's move on to network 2. On network 2, there is slightly the opposite of network 1. And since the parallel circuit has the value of R each. So which to start with? Again, we start with the parallel circuit, or parallel arrangement. Using the same formula, the value of each resistance is R and R. Again, they are showing the same common denominator, which is R. So we don't have to find other numbers or other variables. So we just simply put R as the common denominator and add the upper numbers. 1 plus 1 equals to 2. Again, we flip the fraction. So the value of Rp is R over 2. So the total resistance of R and R can be simplified into R over 2, which is half of each of the value. But we're not done yet. We still need to find RT from network 2, which is 2R. And now it makes a series circuit, 2R plus R over 2. Okay, so we deal with the fraction. We need to find a common denominator. 2R is not a fraction, but we can make it a fraction. So 2R over 1. Simple. Now, what is the common denominator between 1 and 2? Just simply multiply. the numbers. So 1 times 2 equals to 2. Now how do we manage the upper numbers? Divide and multiply. That is the shortcut. Yeah. So 2 divided by 1, 2. And then 2 multiplied by 2r, 4r. 2 divided by 2 is 1. 1 multiplied by r is r. So we are reaching at the final stage. 4r plus r equals to 5r. Why? Since r is basically has a value of 1. So simply 4 plus 1 equals to 5. This is the value for network 2. So the ratio between network 1 and network 2 would be 2r divided by 5r over 2. And we can use the fraction. 2r divided by 5r over 2. So in fraction, division can be switched to multiplication. Then we can cancel out some equal values. In this case, r can be cancelled out on both upper and lower level. So the remaining numbers would be 2 times 2, which is 4, divided by 1 times 5 equals to 5. Done. So our final ratio is 4 to 5. 4 represent network 1, 5 represent network 2. So I think this is done. Okay guys, so right now I want to conclude what we have learned today. So first, from this topic, we can derive or we can conclude something. Number one, that the concept of how electric current flow is the same as how the water flows in the river. So the higher the starting point, then the faster the water will flow. Same thing as the current, the electric current. And the higher the voltage, the higher its difference in electric energy or potential energy, then the faster or the greater its electric current. And furthermore, there is another aspect called resistance. Resistance is the blockage. It is something that is blocking or slowing down the electric current which is flowing through the wire. The main causes of resistance could be from the collision between atoms inside the wires, or probably the metal itself, such as impurities or probably some unstable electron. And also when we discuss about series and parallel, we can also conclude that in series circuit, the resistance, the total resistance will be greater. Why? Since in series circuit, the total resistance is added. If there are two or more resistance, then you have to sum them up. So it will be greater. In comparison, parallel circuit will produce less resistance in compared with the other branches. So let's say if you have 2 ohms, 2 ohms, 2 ohms, so there are 3 of them arranged in parallel, then I can guarantee that the total resistance in those circuits would be less. The total resistance would be less than 2 ohms. Why? Since we are using fraction to find the total resistance. And lastly, electric power, it is the amount of energy that is flowing, yeah, per unit time. Yeah. In this case, yeah, we are describe the power, yeah, in units of watt. The definition of watt is joule per second. It is describing, yeah, the total amount of energy that is flowing through the wire per 1 second. So I think it's enough for today. I hope that this topic will be understood very well, and see you again. Bye.